Hello, this is Tamisha with Educational Tutoring Centers with a brief tutorial for you on naming compounds and writing chemical formulas. The first one that I have here is the binary ionic compounds, polyatomic ionic compounds, and then multivalent metals. Okay, so the bi is the prefix and binary means two. So you're going to have two elements. And the ionic is the combination between a metal and a non-metal, which has a positive charge for your metal, your cation, and your non-metal has a negative charge, which is your anion. So here, for sodium chloride, when those two combine, they're going to have, the name is going to have IDE at the end instead of saying sodium chlorine. You say sodium chloride. And step one will be to write your elements symbols. So sodium is Na, chlorine is Cl, and then you use your periodic table to find the charges. So here, sodium is in group 1. It has a +1 charge. Chlorine here is one step away from your noble gases, so it has a negative. It's a nonmetal, and so it has a negative charge, and it has -1 is its charge. So that's what I've written here, +1 and -1. Some people write 1 minus and or 1 plus and 1 minus. The second step would be if this were not neutral at this point, which it is, because a +1 and a -1 becomes 0, so that makes it neutral. If it were not neutral, you would do your crisscross method as a shortcut to get your subscripts. So here it's just simply written as NaCl. The next example that I have here is calcium bromide. Okay, the charge for calcium, it's in group 2 if you look at your periodic table, and so that has a 2+ charge, and bromine is a nonmetal. It's one step away from your halogens, your noble gases, and it has a 1 negative charge. And so once you do the crisscross method, you'll have a 1, which you don't have to write here as a subscript, and a 2. Okay, so now let's look at these polyatomic ions. And the polyatomic ions are the ones that will be set aside for you in maybe the notes that your teacher has given you, a list of the polyatomic ions that you all will be working with. So let's look at sodium carbonate. Sodium carbonate. Sodium has a symbol of Na, just like here. And so we know that the charge is 1+. And then carbonate is CO3. And the charge on that is a 2-. That charge will be given to you. You don't refer to the periodic table, or you don't have to refer to the periodic table to get that charge. And then you do the crisscross method, and you'll place a 2 down here for sodium, and you would place a 1 here for your carbonate, but since it's 1, you don't have to write it. Now let me show you what happens when that charge that's being brought down as a subscript is not a 1 when you're working with polyatomic ions. This one, for example, is magnesium nitrate. Magnesium is in group 2, so it has a 2+ charge. And then you have your nitrate, which is NO3, and the charge on it is 1- or just -1, or however you would like to write it. Once you do your crisscrossing, the magnesium will take a subscript of 1, which you don't have to write. But this nitrate, since it has a subscript of 3 on oxygen already, when you cross this charge down, you will have to put this in parentheses, your polyatomic in parentheses, so it doesn't look like 32. Okay, now let's come over here to our multivalent metals, and let me show you where those appear on your periodic table. They will be right here in the center. The ones that are on the outside of that, group 1, group 2, group 3, 4, 13, 14, 15, 16, 17. Those are all, the charges are all based on where their group number. So everything here in group 1, other than hydrogen, will have a +1 charge. Hydrogen can either be a +1 or a -1. Because the other location that you might see hydrogen would be on the periodic table right here next to helium. And so it will be one place away from your noble gases, and that's when it will have a -1 charge. Everything here in group 2 will have a 2+ or a +2 charge. And then when we get over here to 13, we'll have a +3. 14 will have a +4, which also at times, because it's right here in the middle, it could either gain electrons or give up electrons. So it'll either have a +4 or a -4 charge. And then for 15, 16, and 17, those are your ones that are going to have a negative charge. And so you kind of work your way backward from the noble gases. So this will be a -1 charge here, a -2 charge for these, and a -3 charge for these. Okay, so these ones here in the middle, these are your multivalent metals because they can have varying charges. And you will see those charges listed here and on the right side of them. Okay, so let's go back here really quick and look at what happens when we're dealing with those multivalent metals. So here, iron 3 oxide. If you notice here, we have a Roman numeral inside of parentheses. Well, that Roman numeral tells you what the charge is on this element. So the element symbol for iron is Fe. The element symbol for oxygen is O. And if you notice, we have a metal with a non-metal, and therefore it ends with IDE. Okay, this here is the charge, so we write the charge there for iron, so you don't have to guess if you're using the 2 or the 3. It'll tell you here in Roman numerals what the charge is. We know that oxygen has a 2- charge, and so when we do our crisscrossing, we end up with Fe2O3. Now, a lot of times students get confused and they think this is iron 2. Well, this is not iron 2. This is the result of doing your crisscrossing. And so this is iron 3 based on that. So let's look at the next one here. We have copper 2 nitrate. Again, in parentheses, it tells you the charge on your element, and it's the element before it, not the element after it. So copper 2, so the charge on copper is a +2. Nitrate is on your polyatomic sheet, and you'll see that it has a 1- charge, and then you do your crisscrossing, and so the copper takes a subscript of 1, and your nitrate takes the subscript of 2, and remember to place that in parentheses. Okay, so I have another video coming with maybe about 3 more concepts, and we'll go from there. Thank you for watching.